Here's an interesting problem that we want to try to point out, and one of which I don't know that your text does a particularly good job, so we want to make sure we add this example. This is the question of, suppose you have a project, and in this case we've got one that's going to be an expenditure up front of $22,500, a project that has returns in each of the next 5 periods of $6,250 per period. We've got a cost of capital or WACC of 12.5%. To decide whether or not to do the project, what we've shown already is you want to say, well, let's begin by taking the time zero cash flows. We want to add to that, we'll go to our function wizard, and under financial, we want to choose the NPV function. And for that NPV function, we're going to discount using our weighted average cost of capital, and we're going to put in the values of the future cash flows here from time 1 through 5. And we're going to end up, in this case, with a negative value. Now, one of the things I want to do, I want to use this some more, so I'm going to put a $ in there between the B and the 1 for purposes that will be seen later. So we tell it OK, and it says, your NPV is negative, reject the project. Now, this was evaluating it by its engineering life, but not necessarily by its economic life. And so we've added another line in here that says, consider the option where you could abandon it and receive some additional funds by selling, by getting some kind of salvage value with it. If you end at 4 periods, you get a salvage value of $5,000. If you end after 3, a salvage value of $11,000, and so on, all the way through each of these. If you decide not to do it, then you're out nothing. Now, what we want to consider is we've got here for the cash flows in each of these individual opportunities, the cash flows at each period T. And this is what we've laid out here in each of these opportunities. Suppose, for example, that what we had done is we had abandoned it at time 4 rather than going through for time 5. We're not going to get any return here, but at time 4 we're going to receive both our $6,250 and the abandonment value of $5,000. Now, in a case like that, what we're going to go through here is to evaluate, well, what happens to the net present value. So we look here and we say, well, it's our time zero cash flow plus our NPV, just as we did previously. So we go to under financial, or here most recently used, to the NPV function. It wants to know the rate. So I'm going to fix it in here at rate $1 so that I can do some copying. And finally, it says, well, we're going to receive these cash flows. And the cash flows, as we've indicated here, are the ones where you get the cash flow for the period plus the abandonment value, the salvage value. Again, negative return, so we're still going to reject the project as a 4-year project. However, as we work our way down here, and we keep adding in the abandonment value to it by stopping at a particular point in time, what you're going to find is that when we look at the 3-year project, suddenly we find a project that we would accept. So while we would have rejected here, we're going to suddenly say, this is an acceptable project. But the other question is it optimal? And again, this is where I think your textbook doesn't go far enough. They stop as soon as they find one here. So what would happen if we had done this but had abandoned at 2 periods? Well, we would reject. Well, what about after 1 period? Now after 1 period, we find a net present value that has a different amount. While we would reject this one, we have a dilemma in the case of the 3-year project and the 1-year project. And the dilemma is this. These are projects with unequal lives. So what we want to note is that abandonment is an unequal life project. And we've shown 2 different ways in which you could solve this. One is by the replacement chain, which is basically you go in there and you repeat the project. So here, a 3-year project would be a repeat of this 2 more times that we've got in here to find out what the overall value is. Or we could calculate something called the equivalent annual rate. And what our equivalent annual, annuity that we would want to have with this, which is basically take the money and invest it to find out which is the better project. So in this case, all the equivalent annual annuity does is it's asking us to go ahead and figure out if I spent $109.05 today to purchase an annuity that lasted for 3 periods, what would be the annuity amount that I got each year? Versus if I spent $77.78 today to buy an annuity that lasted only 1 year. So the number of years according to the end of the project, what would that equivalent annual annuity be? And we want to calculate those, compare. The one that has the higher equivalent annual annuity is the project that we should adopt. So we'll go through here and go ahead and deal with that. Since it's an annuity, what we know is that we're going to be able to use is, under the financial functions, a function called the payment function. So PMT. So if we go in here and we choose the PMT function, what we're going to do is, it says under that PMT function, what is the rate that we're going to use? It's the discount rate of 12.5%. How many periods? Well, this first one is a 3-period project. So we're going to go ahead and select the 3 periods. It wants to know what the present value is. Well, this is an outlay. We are going to spend $109.05 to buy that annuity, which is going to give us $45.79 per year as the annuity. We want to compare that to a 1-year annuity in which we spend $77.78. So again, we want to go to the function wizard, and we're interested under the most recently used of that payment function again. The rate is the same, 12.5%, but the number of periods is only 1. We were going to abandon after 1 period. How much will we pay? Well, it's an outlay, a negative of $77.78, and what we get back in return is $87.50. So pick the 1-year abandonment. And that's how we would make our decision for abandonment. Now, this is similar to what you might have in terms of the value you get out of a car. When do you turn a used car in? Do you keep it till you keep getting enough value that you run it into a ground, or is it something that you want a higher valued one every year? It's simply the embodiment of this practice.